Hi, this presentation covers the FHIR terminology resources, code system, value set, and concept map, and what their construction is and how you use them when you're trying to author those resources. The reason we're interested in terminology is that it's really the basis of shared meaning between different systems. So the resources that you use in FHIR or in some other representation of clinical data, that's the skeleton, but it's really the terminology that provides the muscles in the exchange. So if you're looking at condition resource or a procedure resource, they're probably going to have a lot of different elements on them, but it's the code of the condition or the code of the procedure, or indeed the code of whatever other resource that you're exchanging that really tells you what that condition or procedure is. It's also a very important part of defining profiles. One of the first things that we do when we're customizing how a particular resource should be used for a certain context is to narrow down the set of codes that are acceptable for that resource. And the way we do this is using value sets. In a larger integrated system, having a single reference for terminology is really valuable for interoperability, so that all of the different parts of the system are talking the same language and the same version of the same language. Being able to externalize that terminology to store it on a separate server can make it much easier to update terminology when it changes over time, when a new version arrives. So some of the use cases where we can use FHIR terminology are data entry. So when a user is trying to find one or more codes that are appropriate for their record. For validation, so if you receive data, then being able to test whether the code that you've received is appropriate for the context that you want to use it in. For display or understanding, where you might receive a number of codes and you want to look at what the relationship is between those codes, whether it's hierarchical or perhaps what the properties of those codes are. For mapping, when you've got a set of codes and you need to be able to map those across to some other coding system or some other value set. For analytics, so you might receive a set of coded data and you want to arrange it into categories so that you can better understand it and provide some insight into that data. For authoring, it's very common that you need to make your own code system or value set and concept map, whether that's in the context of profiling or defining sets of codes that are acceptable for data entry, or for defining the sets of codes that are appropriate for different categories in analytics. And that's a big focus of this video. And if you're a server implementer, then you often want your server to be smart about terminology as well. So you want to be able to support terminology-aware search of your clinical resources in your server, for example. So just before we get into the resources themselves, where do these codes live in when we're using FHIR? So there are three data types in the FHIR spec that relate to terminology. The first is the simplest. It's just a code. It's the code type. And it just comes with a single string representing the code that you're interested in. And this data type is used where the underlying code system for the code is actually fixed by the resource that you're using. So for example, if you're looking at the gender element on a patient, then the code system for that element can't vary. So we don't need to provide it every time, and we just provide a code. The second data type is the coding data type. So in this case, we provide a code, but we also provide a system. We can provide a version. We can also provide the display text for the code and whether it's been selected by the user. And this one is used where we're not sure what coding system is appropriate for the code that we've provided. The third data type, and this is by far the most common in the FHIR spec today, is the codable concept. So codable concept allows us to include multiple codings in our data element, as well as a textual representation. So these multiple codings might be the code that the user selected and then some of the codes that it's mapped to, or it might be might represent some other kind of equivalence between those codings that have been provided. When we're using search for these for terminology coded elements in the FHIR spec, we use the token search parameter type. And this is expressed as a pipe separated combination of the code system URL and the code. So we can have the system and then a pipe and then the code. And if we're searching for that, we want to match on both. We can provide just the code with no pipe and no system. And in that case, we're looking for that code to match regardless of what the system is. We can put a pipe and then a code, and that matches when there is no system specified. That's kind of a degenerative case. And we can search for system and then a pipe and then no code afterwards. And that means we're searching for any code in that code system, which can be useful in some circumstances. There are also some modifiers that we can provide for these types of search parameters. So we can provide colon text and colon not, and these work the same as they work for all of the other FHIR search parameter types. Colon below and colon above allow us to search based on hierarchy. Colon in and colon not in allow us to search based on membership of a value set. So whether that code is a member of the value set that you then provide as the search parameter value. And then there's an of type parameter modifier that's only really relevant for identifiers. So this is an example of a very simple FHIR resource showing how some of the terminology typed elements get represented. So we can see this is an encounter resource type. I've got the representation here in JSON. It could equally be in XML. The status element that follows that resource type, that's actually a code typed element. So in this case, we're not providing the system, the code system for that code because it's implicit in the encounter resource definition. The class element, which follows, that's actually an example of a coding typed element. So in this case, we're providing the system, the act code URL that you can see there, and the A and B code. And we've chosen not to specifically state what version of the code system we're using, nor the display text of the code that we're using, but we could if we wanted to. The third element here is the reason code element. It's a multi-valued element. And it's a multi-valued codable concept typed element. So what we can see here is that the single codable concept that we're providing has two codings inside it. So it has a SNOMED CT code. And in this case, we have said which version this comes from. And we've also chosen to say that this was the code that the user selected. And then we also have an ICD-10 code. And probably in this case, it's a mapped code that's been mapped across from the SNOMED code, which we know was the one that the user has selected. And then we're also including some display text, so the suspected COVID-19 for the codable concept. So the three terminology resources that we're interested in today are code system, value set, and concept map. So code system and value set are particularly interesting. They have an N on this diagram because those are normative resources. So that means that they're not going to change in the FHIR spec. The concept map, by contrast, is maturity level, I think 3 at the moment. So although it's had some review and it's been through some HL7 connectathons, it still may have a little bit of volatility as the progression of the standard continues. So what are these resources? So a code system is some set of concepts with a coherent meaning. So they come with a bunch of metadata, so URL, version. Those are particularly important because that's how we identify the resource. They also have a name and a publisher, copyright, etc. And importantly, they can define filters. So these are the things that you can then filter the codes on when you're trying to construct a value set. They've defined properties, and it may be that the filters are filters over property values, although they're not always filters over property values. And properties can also be retrieved in a lookup operation. And most importantly, the code system contains a whole bunch of concept definitions. So these can be arranged in a hierarchy, and each one of them will define a code. They can define a display term. They can define a number of synonyms. They can define a definition. And they can define the values for those properties that we've defined earlier. So the second resource is the value set resource. So a value set resource is some sort of selection of codes drawn from one or more code systems. So it doesn't have to come from a single code system that represents a set of codes that is useful for some particular context. So for example, you might be defining a value set of codes that you want to allow your user to select for a procedure, or You might be defining a value set that represents a set of chronic diseases that you're interested in for the purposes of analytics. And we'll get into how you build those value sets later on, but you can either do it by listing a specific set of codes or by defining rules that govern whether a code is or isn't a member of a value set, so an intentional definition. The third resource that we're interested in for terminology is the concept map resource. So the concept map resource is a mapping between sets of codes in one value set and sets of codes in another value set. And those mappings are represented as a one-to-one mapping between codes, which doesn't, each row in the mapping is one-to-one, but you can certainly have n-to-1 or 1-to-n or n-to-n mappings in your concept map. But each row has a source code, a target code, and a relationship between those, where that relationship can be that the codes are equivalent, or that one is broader than the other, or if we don't know much about the relationship, we can just call it related to. So just a quick recap. Hopefully you're familiar with the very basics of how to interact with resources in FHIR, but I'll give a quick summary here. And the interactions that we're interested in for the purposes of this video are what are called the SCRUD operations. So search, create, read, update, and delete. So this is how we manipulate resources on the server. The search interaction we do using an HTTP GET request just to the resource name itself, and then we can append search parameters onto the end of that. And each resource will define a different set of search parameters. There are also some search parameters that are in common across all resources. We can also invoke the search interaction using a post request if we choose to do so by sending that request to _search. And in that case, we send all the search parameters through as a parameters object in the body of the post request. A create interaction is done using the HTTP post method. So we post some piece of either JSON or XML to the resource name at the FHIR endpoint. So to /value set or /code system, for example. And in that case, we don't send through an ID, and the server will send us back an ID for that resource once it has been created. The read interaction, there are two variants of the read interaction. So the first is what we would call the normal read interaction. That uses the HTTP GET method, and that gets sent through to the resource name / the ID of the particular resource we're trying to read. The second variant of the read interaction is a versioned read. So in this case, we might be interested in an old technical version of the resource, for example, and we can send through the resource name and the ID, and then _history and the number of the version that we're interested in. So version 1 or 2 or 3, for example. And that's sometimes called a VRead, that versioned read interaction. The update interaction uses the HTTP put method. So we start with our JSON or XML representation of the resource. In this case, it does have to have an ID, and we send it through to /the resource name, so /value set / or code system or whatever, / the ID of the resource that we're trying to update. And the final interaction is the delete interaction. This uses the HTTP delete method, and we send that through to /resource name /ID, and that can delete a resource from the server or ask to delete a resource from the server. And all of these interactions will give us back HTTP status codes and possibly bodies in the response as well to indicate whether the interaction we've requested has been successful or not. And if it has been successful or not, then what happened, and if not, then why not? So the use case that I'm particularly interested in this video is really about authoring terminology resources. And there are lots of reasons why we might want to author terminology resources. For example, if we're creating a new user interface for entering clinical data, then we may need to create value sets for data entry fields in that user interface. If we're building FHIR profiles or editing FHIR profiles, we may need to create some new value sets for bindings for those profiles to restrict the sets of codes or perhaps just explain the sets of codes that are acceptable under that profile. We may need to represent proprietary or local code sets as a new code system resource. Or we may need to create a concept map for example, mapping local codes to a standard code system, or of mapping clinical detailed codes through to a more coarse-grained billing or analytics code system, for example. So what I'm going to do to explain that is just to go through these resources one at a time to show some of the interesting parts that you should know about when you're trying to put these resources together as a FHIR resource. So the first we'll look at is the code system resource. The code system resource has a lot of metadata elements on it, and these are interesting not just for the code system resource, but these elements are pretty much in common across all of the terminology resources. So the code system resource is really identified by a URL and a version combination. So when you're referring to a code system, either from a value set or from a concept map, then the way you refer to that is using its URL and its version. So those are important elements for identifying the code system. There are a number of elements on the code system resource that kind of just provide informative metadata that don't change the behavior of the operations on the code system, but tell us about its origins and who's responsible for it. So we have a name, which is a machine processable name for the code system, a title, which is a human readable name for the code system or title for the code system. It can have a number of identifier elements. So that's a multi-valued field. So that might be the official OID of the code system, or it's what it's referred to in some particular metadata registry or something like that. I can have a status of the code system, which is whether it's active or still in draft, for example, whether or not it's an experimental code system, the date of the code system, so when it was last updated, who the publisher is of that code system, the context of the intended context of its use, the jurisdiction it's intended to be used in, its description, its copyright, etc. Then there are a set of metadata elements that can actually change the behavior of the code system. And some of these that are particularly interesting, the hierarchy meaning can change the way that operations like subsumes and closure work. So we can either have an is a hierarchy where each element in the hierarchy is substitutable for its parent, or we can have a classified with hierarchy like you might see in classification type code systems like ICD. The version needed element is interesting because it goes to what is called in the SNOMED CT world, what is called concept permanence. And this tells you whether the version of that code system is always needed to be supplied, because the meaning of a given code could change from one version to the next. The content element tells you whether what you're seeing in that code system resource is a complete representation of all the concepts, or it might be a fragment or an example, or it can tell you if that code system resource is actually a code system supplement that is intended to add detail to some other code system. And the supplements element on code system, that goes along with when you say the content type is a supplement. You then can tell it which code system it is that this code system supplement is adding detail to. And then the count element tells you how many codes you should expect to find in that code system. The final metadata elements that are of interest are the properties and the filters. And this is where we define the types and descriptions of the different properties and filters that we can expect to find on the code system. So if we look at this example over on the right here, this is the first part of a little code system that I'll use as an example of Australian jurisdictions. And you can see we've defined two properties here. One is this capital property, and it tells us that this is the capital city of the jurisdiction. And it tells us, most importantly, that this is a string typed property. And then we've got a neighbor property here. This is the neighboring jurisdiction, and it tells us that the values of this property, when we encounter them later in the code system, they'll be of type code. So obviously the most interesting part of a code system resource is the concepts that it defines. These concepts can exist in a hierarchy, and there are a couple of ways to do hierarchy in a FHIR code system. One is to use nesting. So if we look at this example over here on the right, what we can see is that we've got a top level concept here, AU, and then we've got a nested concept, AU state, and within that, another nested concept, WA. So that's that nesting style hierarchy, which is really useful if you've got a single hierarchy, a tree type structure. If you do have polyhierarchy, where a concept can have multiple parents, then it's not possible to represent that using nesting. And so a convention that you can use is, instead of using nesting, you can populate the parent and child properties of each code to represent what those hierarchical relationships are. So in addition to the hierarchy, for each code, we can specify what the code itself is. So for example, AU or AU state. In this example, we can specify the display term, we can specify the definition of the concept, and we can specify designations. This is usually used for synonyms, either synonyms or translations. So what we can see in this example here is that I've defined a synonym. Each designation can have a use, and that's where we say that this is intended to be a synonym. So that code that we're using there is the SNOMED code for synonym. And then we can define a set of property values. So for this WA concept here, what I've done is I've defined the capital property to be Perth. I've defined the neighbour property to be NT, and I've defined another property value for neighbour as SA. So those properties can be multi-valued. You just repeat them for each value. So one thing that's worth mentioning is a special type of code system resource, which is a code system supplement. So this is something that's new in the R4 release of FHIR. The reason it was introduced and what it allows you to do, it does allow you to override the display term. So if you've got a standard code system that you're using, but in your particular context, you use different display terms, then you can define those in a code system supplement and override the original display terms. You can also add new designations. So those might be new synonyms, but more commonly, they can be new translations into a different language. You can add properties to the code system. One thing you can't do is add new code. So it's not permitted to add new codes in a code system supplement. The way it does this is you set the code system supplements property to point to the original code system that you're adding detail to, and you set the code system.content element in your supplement to be supplement. And by far the most common purpose of code system supplements so far is for language translations, where you've got a code system that's been published, perhaps it's in US English and you want to provide some localized translations, perhaps into UK English or perhaps into German or Italian or Japanese. You can do that using a code system supplement. So the second resource that we'll look at is the value set resource. So like the code system resource, this has a bunch of metadata properties that you can define. The most important, once again, are the URL and version elements. And then it has a whole bunch of other metadata elements, and I haven't listed them here because they're very similar to code system, particularly those elements that describe the code system rather than changing its behavior. Most of those exist for value set as well. So things like name and title, publisher, copyright, identifier, and so on. The really juicy part of the value set resource is the compose element, because this is really where you define which codes are or aren't in the code system. And the way it does this is by defining a set of include and exclude statements. And there are 4 tools that we have for building up these include and exclude statements. The first is that we can include or exclude a whole code system. The second is that we can include or exclude a list of codes, so an explicit list of codes where we enumerate what those codes are. The third is we can include some filters. So these are a triple of a property, so the name of the filter that we're filtering on, an operator, so this might be equals or it might be something like descendant of, and then a value. And then the fourth tool that we have is including or excluding members of other value sets. and those are the building blocks, but we can then start to combine those. So if we include one or more of these things in the same include block, then they're ANDed together. So both things must be true in order for that to be satisfied. Whereas if we define multiple include blocks, then those things are ORed together, so either thing can be true. So for example, if I were to include two filters in the same include statement, it would only match codes that satisfied both of those filters. Whereas if I were to put those filters in separate include statements, it would match codes that match either of those filters. And the way that the value set compose element is processed at runtime is that it will process all of the include statements first to work out what codes can be included. And then only after calculating those includes, it'll move on to work out what the excludes are and take those out of the list of codes. The other element that's interesting in a value set is the expansion element. The place where you mostly see this is in the value set that comes back as the result of an expand operation. And if you're interested in the FHIR operations, there's another video that's available for those. So this is where you will find the list of codes that actually match a value set that are included in a value set with respect to a bunch of parameters that are provided for an expansion. So that might be a text filter, that might be a count or an offset limit, or the various parameters that you can pass to the expand operation. So the final concept, the final resource that I'll describe is the concept map resource. Once again, like code system and value set, it has the URL and version parameter elements that you can use to identify the resource. Also, like code system and value set, it's got a lot of metadata about the definition of the resource that you can populate, things like name and title, identifier, publisher, copyright, date, status, etc. Where we get into the actual functional definition of the concept map, it can define a source and a target value set for the map. So in this example, what we can see up here is that I've got a source value set, which is my Australian mainland states value set. And then there's a target value set. In this case, it's all of SNOMED. We can then, for the actual map rows themselves, these are defined by group. And the reason they're defined in multiple groups is just as a shorthand so that we don't have to repeat the source system and the target system for each mapping. So because the concept map maps between value sets, and because value sets can draw codes from multiple code systems, it's always possible that you could be talking about code A in one code system or code A in another code system. So we need to clarify which of those we're doing when we're stating our map relationships. So what we do is we group them together. So this first group that I can see in my example map here, all of the rows in this will have as their source code system, the jurisdictions code system, and their target code system, the SNOMED code system. And then when we get down into the elements of the map, what we can see is that the source code here is QLD, and we know that that comes from the jurisdictions code system. And for each of those elements, we define the source code and then a number of target codes, and for each target code, the equivalence relationship that exists between those. So here we're saying that the QLD code in our custom jurisdictions code system is equivalent to this 223.778.006 code from the SNOMED code system. And we can define multiple of those elements in each group and multiple groups within our concept map. So just to wrap up, there are a few well-known terminologies that we use when we're using the FHIR Terminology Services API. So the sort of big standard terminologies like SNOMED CT, LOINC, ICD-10, UCOM, etc. These have standard and specific mappings into the FHIR terminology resources, with certain parts of the code system resource being fixed. So some of those are that there will be a fixed URL for those code systems. There'll be a fixed versioning format for those code systems. They'll define a standard set of code system filters and properties. and often they will define implicit value sets and implicit concept maps. So what that means is that once you've got that code system in your FHIR terminology service, there are a bunch of implicit value sets that will be there without you having to define them. And I'll show some examples of what those are in a moment. And likewise, there'll be some concept maps that exist on the server without you having to define them explicitly. So this is a list of some of those built-in characteristics of the SNOMED CT and LOINC code systems. So the SNOMED CT code system has this http snomed.info/fct URL. That's the format of the URL. And for SNOMED, the format of the version string is actually that URL slash the edition of the code system slash version slash and then the date of release of that particular edition of SNOMED. So for the UK edition, for example, this will have the edition code, which is 838 something 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 107, and then slash version slash 2020 0930 or something like that. There's a bunch of properties to define that are defined for SNOMED CT. It's actually a very, very large set. So all of the relationships that exist in SNOMED CT, so finding sites or things like that, they're all available as FHIR properties, and then they're also available as FHIR filters. So you can actually filter the SNOMED CT code system based on those SNOMED relationships. There's a couple of other properties that are available. So normal form can get you the normal form of any concept in SNOMED. A module ID can tell you which module that concept has come from, etc. For filters, all of those are available as filters. You can also use subsumption as a filter. You can use a ref set as a filter. So you can look for all concepts that are a member of a certain ref set. And you can use ECL expressions as a filter if your server supports it, as it is supported by Onto server, for example. SNOMED defines 5 different types of implicit value sets. So the first one is the simplest one. It's the implicit value set of all codes in SNOMED. So that's http snomed.info/sct via VS. The second category of implicit value sets is the hierarchy-based implicit value sets. So if you use a URL for a value set that looks like this, ending in FHIR VS equals ISA slash and then some SNOMED code, that will give you the value set representing all codes that are a descendant of that code, including that code itself. The third implicit value set is the value set of all of the ref sets that are available in that particular version of SNOMED. The fourth is all of the codes in a given ref set. So for this, we can say FHIR VS equals ref set slash and then the ID, the concept ID of some SNOMED CT ref set. And that will give us a value set consisting of all members of that ref set. And the fifth and probably most expressively powerful implicit value set is the ECL implicit value sets. So for this, we can construct a value set URL ending in FHIR VS equals ECL slash and then some sort of ECL expression. And that will give us the value set corresponding to all codes that satisfy that ECL expression. SNOMED also defines some implicit concept maps. So the most interesting of these are the historical associations concept maps. So if we can use the translate operation, for example, with a concept map whose URL is http snomed.info/sct FHIR equals, and then the ID of one of the 4 historical associations ref sets, and that will correspond to the concept map of all of those historical associations maps, which are basically maps from retired codes to things that they've been either replaced by or that they're the same as, or things like that. LOINC also has some of these fixed characteristics. So its URL is always http loinc.org. And you can append a version if you want to be specific about a certain version. The LOINC version syntax is just sort of x.y, so 2.68 or something like that. It defines properties for all of the LOINC axes, so method, type, time aspect, property, etc. As well as for status, which can tell you whether a code is deprecated or not. It defines filters by multi-axial hierarchy, as well as by part, and a bunch of other filters. And it defines a few kinds of implicit value sets. So all of the codes in LOINC is represented by this implicit value set here, loinc.org/vs. You can also use implicit value sets by multi-axial hierarchy by just appending the LOINC part at the end of the implicit value set URL, and that will give you all of the codes that descend from that LOINC part in the multi-axial hierarchy. And you can also retrieve them by answer list. So if you put the code of an answer list at the end, then that will represent a value set consisting of all of the answers that are in that answer list. So that's a quick introduction to the FHIR terminology resources. If you're interested in more information, there's another video that's available about the FHIR terminology operations that you can use with those. And if you're interested in authoring those, then we also have videos about how to use the Snapper terminology resource authoring tool to construct some of these resources. And if you have questions, please feel free to send them through to us.